So to fully understand how Git works, we need to take a small side trip away from Git to talk about hashing functions. If you're familiar with the topic, the concept of hashing, you could skip this or maybe just skim it. We'll get back to Git specifically in the next video. But of course, this is all connected, so let's get going. So you've probably come across, I don't know why I said probably, you have definitely come across these long strings of characters. They are hexadecimal characters, exactly 40 digits long. If you're not familiar with hexadecimal, it's base 16 instead of base 10 decimal for a numbering system. So base 16 means we run out of digits that we use, at least in the decimal system, 0 through 9. So then we move on to letters, A, B, C, D, E, and F. I forgot F. Okay, so we end up with these very long strings, which are numbers, and they're all exactly 40 characters long. We've seen them before. I've used the term commit hash or just hashes. So what exactly are those? Well, they're the output of something called a hashing function. So hashing functions are a family of functions that have one goal. They take inputs of arbitrary size, meaning inputs of a variable size, small, large, and then spit out outputs of a fixed size. So in this example, whatever this hashing function is, it spits out, I'm not sure how many characters this is, but whatever it is, you can see that both outputs are exactly the same length, same number of digits. It doesn't have to be hexadecimal. Any number can be turned from hexadecimal to decimal or to binary, right? Numbers are numbers. This is just one way of representing them. They would be a little bit longer if this was a decimal number. Anyway, it's a fixed size. So the input here is a sentence. The input here is 3 characters. The input could be a file potentially, or it could be a single number, and it spits out fixed size outputs. So you may have come across hashing functions in computer science contexts, talking about data structures like hash tables, or you may have come across the term cryptographic hash functions, which is a subset of hash functions. They do the same thing, right? They map data of some arbitrary size to an output of a fixed size, but they have a couple of additional constraints, and this group of hashing functions have a whole bunch of different applications in information security, digital signatures, cryptocurrencies, as well as Git. So I'll just run through some of these really quickly. Probably the most important one to talk about up front is that cryptographic hash functions need to be deterministic, meaning that the same input always yields the same output. In other words, if we go back to this example, I love chickens should always yield this output. Whatever it is, if that's the input, it should always yield that output. LOL should always yield this output. So whatever the output is, it should be consistent. There shouldn't be any variability in what you get for the same input. Another constraint is that a cryptographic hash function should be a one-way function, meaning that if you have the output, it shouldn't tell you anything about the input. And along those lines, you shouldn't be able to guess or infer anything about the input. You shouldn't be able to reverse engineer if you have the output. So if I were to implement a password login authentication for users on a website, we use a hashing function to store the hashed output of a password. Let's say these are 2 passwords. If somebody gets access to our database, a hacker, a bad actor, they see these password hashes. They shouldn't be able to infer anything about the actual passwords. So that's important in a lot of situations. Also, a small change in an input should yield a large change in the output. It goes along the same lines, right? I shouldn't be able to guess I love chickens yields this. I should not be able to guess what I love chicken will yield. They shouldn't be connected. And then also, it should be unlikely to find 2 outputs with the same value. We want to avoid collisions whenever possible. So mathematically, with these hashing functions, it is possible to have collisions, of course, but the probabilities are so low that we really don't need to worry about it. Anyway, those are the basic rules of cryptographic hash functions. Now, we're talking about Git here. We're not talking about cryptography. We're not talking about authentication or cryptocurrencies, but Git uses one of these hashing functions called SHA-1. Although this actually is set to change eventually. It's something that the group behind Git has said, we plan on changing, we don't know when, and it's going to be a nightmare to change, but we plan on it at some point. But at the end of the day, there will be some replacement that will be just another hashing function. And this one, SHA-1, has been around for a little while, and it's a hashing function that always generates 40-digit hexadecimal strings. So the output size is fixed, right? We've talked about that. And all of the hashes we've seen are the output of the SHA-1 algorithm. So there are a handful, more than a handful, but there's a set of known or commonly used cryptographic hashing functions, including the SHA family, but there are others. MD5, ECDSA, is that what it is? ECDSA? I can never remember. Yes, ECDSA. Anyway, there's a group of these algorithms that are most commonly used. I just want to end this video by demonstrating some of the principles of this SHA-1 algorithm or any cryptographic hashing function. There are many websites that let you play around with different hash functions. So I've selected SHA-1 here, and then I can put any input in here like H, lowercase. I'll hash it, and here's the output that we get, 40 characters of hexadecimal. But I could also do HE, or how about a capital H, just to show you. We get a very different output, 27D54. Now we have 7CF, completely different. There is no connection. Now, if I do something that's really, really long, like imagine a whole file of JavaScript or a couple thousand lines of CSS. I'm just going to duplicate this a bunch of times. We're still only going to get 40 characters out. Okay? So Git uses this algorithm, SHA-1. You can see some of the other hashing functions here, common cryptographic hashing functions. But for us, we only care about SHA-1. We don't need to know anything about how it works. We just need to know that it satisfies the requirements to be a cryptographic hash function. Even if it's not that commonly used these days outside of Git, it is used in Git. And let's talk about how in the next video. So that's coming up.